What is the inverse square law, first of all?
I1 over I2.
Okay, I1 over
This
I2.
one's better so far as more
Oh, okay, let's move back.
Mm.
Oh my god, now it's confusing. No, I can't unsee it.
Okay, so if the 1 is on top here, what goes on the top here? 2, right? So we have
D2
D2
squared.
Right, squared. And then D1, right? So inverse, right? These are inverse to each other. Inverse square law. So inverse square law tells us that the farther we get from our source of radiation, the less radiation we receive. Okay, at its most basic, that is what the inverse square law tells you. So knowing that information, you can already begin to kind of sanity check your answers. You can check your answers to see if they make sense or not. Like if you do a math question involving inverse square law, and you are going, your distance is going farther away, and the value you calculate for the amount of radiation being received has gone up, you know something has gone wrong, correct?
Yes, sir.
It should not be going up because inverse square law says that it should be going down. So now let's take a look at how we can actually use inverse square law. For example, let's say that our original SID is 80 inches. Let's say our new SID is 40 inches. And let's say that our original intensity is, let's use an easy number. Let's say that this is 4 milligrays. Okay,
So what,
just making up a number here.
so what is it in original intensity?
4 milligrays.
Milligrams.
So the question is, what is our, what is our new intensity? Okay, so how would you solve this, Emily?
Okay, so the original
So let's just start putting things in places. So I1, what goes up here? 4. Okay, so what number is that?
Oh wait.
4. Great. So we have 4. Okay, now they go the same. All right.
Does that mark it?
All right, so up top is 4. Okay, what's down here on the bottom? All right, our question mark. So we'll call it X.
Oh.
All right. So going back to our old algebra days, right? Where if you didn't know, we called it X, right? So here's our X. Okay. Okay, what's on top here? Okay, so let's see, Emily.
40.
Who's on TV?
Very good. New distance 40. Oh, wow, that's. Okay. 40. Okay, very nice. And then, what is down here, Emily? 80. Very good. All right. So now we have set up our equation. Okay. So, how do we solve this? What is our first step?
Square.
Very good. So let's simplify. Let's square our numbers first. So we have, right over here, we still have 4 over x. But on this side, we have 40 squared.
14 to
Okay,
40.
so anyone have their calculator out?
But do everyone's cancel the 14, 40 and 80 to 80.
Okay, and what about 80 squared?
64.
6,400. Good. Okay, so does this look familiar?
Yeah.
Yes, we did this last week, right? And so we said we can just cross multiply here. Okay, so I'm just gonna do my lazy way. Right, I'm just gonna do my lazy way just like this. So I'm gonna take my 4 and multiply by 6,400. Anyone feel like doing this for me? Great. And now I'm gonna divide by 1,600. All right, and my answer ends up being 16. So x equals 16.
So the new intensity would be 16.
Correct, so this is 16 milligrams. So let's check to make sure this makes sense. My original SID was 80, correct?
Mhm.
I went to 40. So did I get farther or did I get closer?
Closer.
I got closer. If I got closer, do we expect the amount of radiation to go up or to go down? We expect it to go up, inverse, right? If distance goes down, radiation goes up, right? They're going opposite, right? Inverse. So distance goes down, amount of radiation goes up. We expect more radiation. So, did our radiation increase?
Yes, so it has increased.
Yes, it has increased. How much did it increase by? Great, it increased by 4 times. How much did our distance decrease by? Correct, by half, right? So do you see? 2 squared is 4, right? So that's why this is called the inverse square law, right? Not only do we have squares here, but if you double the distance, right? If you change the distance by a factor of 2, then the intensity changes by that square, 2 squared. It changes by a factor of 4. So this is how we can make use of the inverse square law. We can calculate, for example, how much more radiation we will have when the distance changes. So, think we can try another one?
Yeah.
Sure, yeah.
Like a harder one. Well, one that'll be fair game. Yeah. Like I was thinking 25, 36.
Well, I'm not going to give you every single number possible.
Well, no, but one that'll be like fair game.
Fair game, okay, fair game. So,
0.5.
all right, so let's change up these numbers here. Okay.
We use brackets on this too? Oh, no. Well, yeah, you convert the fractions into.
Now, let's say our original SID is how old? Let's say our original SID is 36 inches. And let's say that at that original SID, our intensity is going to be, let's say, 16 milligrams.
Oh, he did. Oh.
4 extra.
Mhm.
Like, you got there watching
That's
all
not
of
fair.
this.
Yeah,
one.
We take tests when
That's
we
right.
are watching.
Be careful during your tests, right?
Yeah.
We'll zoom in.
All right, and then let's say our new intensity is 4 milligraves. Which means, what is our unknown? Right, mu SID is now our unknown. So, let's see, who do I want this time? Okay, Shaheen,
Yes, sir.
let's set up this equation. So what goes on top here?
So original intensity will go up. Sorry, that will be x. Let's say the original intensity is x. So
Oh,
16 you've already done.
16, very good. Okay,
New-
what about down
New
here?
intensity is 4, sir.
4, good. Okay, what about up here?
So it will be original density is original SID is 36. We'll put 6 into 6, sir.
So this is original SID?
Distance is
Distance.
distance squared.
2.
Do
Distance
we have
squared.
original SID, new SID, original intensity, new intensity?
So which one is our distance number 2? Is it this one or is it this one? Which one is our second SID?
So our second SID is the one we're finding out, sir. Number is x, sir.
Good. So
X,
X,
x, and distance 2 is so original distance is original is 36. We'll put 6 into 6.
so
Yes, it does. Right now, it's the
What are you
36
putting down?
squared. The 36 into 36. Sir.
good. So down here we have 36.
Question.
So are we done?
No, now
Is
we-
this correct?
Let me just
That's
check
better
again,
than
sir.
correct, but
Okay,
I-
all right, let's
let
make
me
for
just
sure.
check, sir. Original intensity is 16. We've got that, sir. And we've got new intensity as 4, so we've got that. And this new SID D2 is the new SID, which is x squared, sir.
X squared, very good.
So, and that's all. And
Right.
now we cross multiply, so we have 16 into 36 into 36. So we're going to cancel, so that makes it smaller.
So, first of all, let's simplify. Let's do our square. So what is 36 squared?
So, sir,
1296.
Good. 1296. Okay, so now we can do our cross multiplication.
so why wouldn't we show small and then make this number small so that it's easier?
It's going to be very hard for you to
No,
cancel these out.
sir, we put 36 into 36 and we just cancel out. So. No?
No, you can't go down to square.
It won't work like that.
That's 36 squared.
Yeah.
So, again, we're going to do this. So 1296 times 16. All right, divided by 4.
5,184.
5184, very good. So,
The square of that is
x
72.
squared equals 5184. But are we looking for x squared?
No.
Very good. We're looking for x. So we need to take the square root of both sides. Which means x equals what?
72.
Very good. X equals 72. You should have the square root function on your calculator.
If you have an iPhone, turn your iPhone sideways.
Oh, there you go.
Can
Looks so
you do it mentally?
Lost because I
Thank
thought it was
you.
4x squared, right?
Thank you,
So
Jane.
Yeah, it's
18.
Which one would it be on the
Yeah,
Yeah, which one do we do those?
So for example,
Oh, and turn it sideways.
it has a calculator and a phone on.
And
I'm lost.
Hindi
So, if that cross multiply, I have to do 4x squared, right?
Ano to? Saan ka plan? Paano ba?
So you look for the symbol like those.
So, he did
That one's cubed. That one's two.
1296 times 16 divided by 4.
Okay, thank you.
That's like easy. Yeah, that's easy. You get the same answer.
Okay.
So do 1296 times 16 divided by 4. You get 5,184.
Yeah. Now, I didn't have room for notes on my big one since I.
Yeah, he taught us that yesterday, but that's the first time learning. I've never seen that before. But
Okay.
it works and it's easier.
So, any questions about how we got to 72?
Okay, so the other one, we did the original and the new SID were divided by 2. And the bottom, the intensities were multiplied by 4, so now we're increased.
So this time we went up by 2, right? So here we went down by 4. Do you see that? So once again, 2 squared is 4, and then we just went in the opposite direction. Any other questions about this? So,
And it's always going to be divisible by a whole number?
will this always be a whole number? Ah, that's a great question. In fact, that's a perfect question to lead into the next example. Will this always be a whole number?
Something wasn't right.
Or has Mr. Phung just been purposefully choosing whole numbers to keep the lessons easy?
Yeah.
Alright, so now let's go to the next step, which is so will you have SID calculation the registry? Awesome.
Are we allowed a calculator? Are we allowed to use calculator?
It comes with a calculator.
Oh.
Their software also has a calculator, just like exam. So,
Remember in high school when they said you're never going to use a calculator in real life?
So did you show us how to multiply
When did this
under the
happen?
calculator?
In high school?
Some
you never had
calculators is
to?
different, right?
different? No, should never be different.
Because you only use calculators.
That's what I was going to say. Like, I only used a
I
calculator.
calculated everything
Simple
in
math and put it
my
on a calculator.
the exam because I didn't know how to multiply with the app that was given.
So we'll need to discuss that after class. We'll have to discuss that after class. Okay, let's go back and do something
Give us a hard one. No, give us something. Yeah, if it's hard, okay, but. No, we're looking for like not gonna be test.
All right.
No, because when I see these on the test, I'm gonna be only. I'm gonna count and skip them again.
Okay, so who do we want this time? Who looks like they don't want to come up here?
All of us.
Who looks like they don't want to answer?
Oh, we have to go with this.
No, but that's long.
Here, I'll choose for you.
You must choose.
Oh, no.
I mean, rather than volunteering other people, I feel like you should volunteer yourself, right?
Oh.
There's Carlo. Right here. All right, come on over, Carlo. Come on over,
That's
Carlo.
good stuff.
Imagine if Cat answered and said, I volunteer them as tribute.
I know, right? She just wants to be on the camera. She's like, why not this phone is
All right. Okay, so it's a bit hard for you to see over there, I think. So we have you right here in front of the board. These are the numbers we have right now. Okay. How would you set up our equation here? What goes on the top left here?
The 40? No, the 72. Alright.
Right here. For I1, our first intensity.
4.
4, very good. That's a good question. It's a cursed board. Eat smart crews. Okay, 4. Great. What goes underneath the 4? X. Very good. Okay. What goes on top of it? 40.
And then 72. And then square, right?
Okay. Which ones get squared?
The 52 and the 40 and 72.
40 and 72. Very good. All right.
So the
The
new
USID is 72. Why did you put 40?
Isn't there split 72?
What you trying to get there, y'all?
I was trying not to say that.
So, what do you think, Carla?
This should be backwards.
Backwards. So what goes on top then?
72.
72. Okay. What goes on the bottom? 40.
I got it right.
All right. Are we okay like that?
Mm-hmm.
Better now?
Mm-hmm.
Okay, good. So, from here, what is our first step?
72 times 72. Oh, I'm sorry.
Squared first. Okay,
Simmer
great.
down.
So,
Like, I'm just trying to help. It don't work at all. I don't know what's wrong.
I'm playing with roulette with these markers. Okay, so 72 squared. All right, thanks everyone.
5,100.
40 squared.
Sorry. I thought you were asking Carl.
1600. All right, thank you.
Mr.
I
Phung's
appreciate
right.
that. Is it?
I'm gonna zoom out. Watch this.
That's true.
Seems to be that. All right. Zoom in. All right, so are we okay with this?
Yeah.
So far, yes. Okay. So from here, Carla, how would you like to solve this?
We would cross,
Okay.
say we do the 4 with the 1,600.
Okay, so you said 4 and which one?
The 1,600.
1,600. What do we do? Add, subtract, multiply, or divide?
Multiple.
Multiply, great. What is 4 times 1,600?
6,400.
Great, 6,400. Okay, and then what do we do?
And then the answer you get, you know, we're going to divide it by it.
So we divide by 4184. So what's 6,400 over there? Or, sorry, 584.
Yes.
X equals, what is that?
1.235.
43? 23. 1.23.
Okay, I hope you give us like this, then it'll be easier.
What did you get, Colton?
I just added one more decimal, I put 3. It's like 1.235.
235?
Yeah.
Do you want to be fancy? 1.235? Alright, so X is 1.235. We do have a decimal now, right?
Mhm.
It is not only whole numbers. But does this decimal make sense? Yes, Jay.
How many trailing decimal points are we supposed to have?
Good job.
Doesn't matter, however many are in your answer choices.
Okay.
Thank you, Carla. So, does this number make sense? We had a very similar question last time, didn't we? Right, when it was 40 and 80. And what was our answer?
No, it's 40 and 72.
Oh, it's-
Yeah. No, it was 80 and 40.
all right, we
You're
did
talking about the
we did
first
it the
one?
other way. That's right, we did it the other way. First one we did 80 and
40.
40, and we went from 4 to 16. Right, this time, now we are going which direction? 40 to 72. What's happening to our distance?
Increasing.
Increasing.
Increasing, good. what's happening to our intensity? Decreasing. Do we expect it to decrease?
Yes, sir.
Yes.
Okay, so that does fall in line with our expectations. Okay, 40 to 72, how many times is that? Is that 2 times?
No.
No,
Less.
it's a little less than 2 times, right? 2 times would be 80. 72 is a bit less than 80. So, our original intensity, right? Normally we said if we go up by 2, we go down by how much? 4. So 4, if we take 4 and divide it by 4, we would get 1. But because we are slightly less than 2, right? We divide by slightly less than 4, and so we have something slightly bigger than 1. So, does this make sense? Yeah, this makes sense. This looks like a good answer. So, inverse square law, right? Main thing is just to figure out which number goes where. Make sure you don't accidentally flip them. And then once you have everything plugged in, simplify, do your cross multiplication, get your answer. Once you have your answer, don't move on yet. Look at your answer and check to make sure it makes sense. Is it going the correct direction? If I'm expecting it to go up, is it actually going up? If I expect it to go down, is it actually going down? If it's going the wrong way, what likely happened?
Yeah, you just did it wrong.
Mathematical error.
Correct.
You got a flip flop.
Correct. These two are probably flip-flopped if you're going in the wrong direction. Does that make sense? All right. So, any other questions about inverse square law? Now, do we all understand why inverse square law is a thing? Can you think of anything in your everyday life that also works off the idea of inverse square law? Light. Okay. I mean, light is radiation, so we would also expect it to follow the inverse square law, right? So, very easy demonstration. Everyone has their phone on them, correct? Everyone's phone has a flashlight on, correct? All right, let's all pull out our phones and turn on the flashlights. And just take your flashlight and aim it straight down at the desk.
Oh.
No, please. It's not a concert. Yep, just take it and aim it straight down at the desk.
Oh, I'm on the floor.
Yep, aim your phone at the desk. All right, and take a look at how bright the light is on your desk. Now, increase the distance. What happened to the light? Okay, bring it closer. What happens to the light?
Gets closer.
Bring it away, bring it closer, bring it away, right? So, when you bring it close, it gets brighter on the table, yes? You bring it away, it gets darker on the table, yes? So, light also works off the idea of inverse square law. Right? The closer it is, the more intense the light becomes. The further it is, the less intense the light becomes.
Is that true for most radiation?
Yes.
So like heat and all that?
Correct. So, for example, another type of radiation, sound. If you're sitting here in the front row, you'll hear me much louder than if you're sitting all the way in the back, correct? So if I decide to give my lecture like this, right? So I'm talking like this, then yeah, Shaji and Jay and Shaheen, they might be able to hear me. But Veronica, can you hear anything I'm saying? Okay, well at least you heard your name, so that's good. But if I was giving important information like the answer to number 14 on the test is going to be B. Some of you may have heard that, some of you may not have. Close. Or A, or C, or D, one of them. Right? So, right, once again, right, sound, radiation, so also follows inverse square law. So just keep in mind, X-rays do the same thing. The closer you are to the source of the X-rays, the more intense they will be. The farther away you are from the X-rays, the less intense they will be. And they follow this relationship, this square relationship. So you increase the distance by 2 times, and that intensity goes down by 4 times.
Is that why megaphones work? Like the little speakers with relation to sound?
I'm not sure what the connection is here.
Well, I mean, it's that image, essentially, is it not?
So, what this image is showing is that, for example, let's say that we are at this distance here. So the radiation will all expose an area this big, correct? So all the radiation here will expose this area. As you increase the distance, that radiation becomes spread out over a much larger area, right? Here it covers an area of 1. Here, that same amount of radiation now needs to cover an area of 4. So each part of this receives 1/4 the radiation. Does that make sense? So you double the distance, intensity goes down to 1/4. Right? You triple the distance, now that radiation needs to cover an area of 9 squares. So each square only gets 1/9 of the original radiation. Right? So distance of 3, right, went up by 3 times. 3 squared is 9. So this went down to 1/9. So it's just another way to illustrate the inverse square law. Okay. Any other questions? Is everyone okay with shielding and radiation protection? So, if I asked you what the 3 core principles of radiation protection are, you answer time, distance, shielding. Very good. Great. Yes.
Will we be expected to memorize how thick the lead should be for shielding in like secondary barrier?
Yes. Good question. So you do need to know the thickness for primary barriers and secondary barriers.
Like 1/16?
1/16 for primary. Good.
1/32 too.
Good. 1/32 for secondary. Is that 1/16 inches, centimeters, millimeters, feet?
Inches.
Inches. Very good.
EQ.
If I say quality, you say
KVP.
quality.
KVP.
Quality.
KVP.
Good. If I say quantity, you say
Mass.
good. Quantity.
Mass.
Quantity.
Mass.
Very good. Mass. What part, which of those 3 principles of radiation protection does mass fall under?
The fungus.
Number of X-rays.
Mass.
So what are the 3 principles of radiation protection? Time, distance, shielding. Which one does mass fall under?
Time.
Why does mass fall under time?
How many times you're shooting? X-rays?
What is the
right.
definition of mass?
Time.
The number
It's
of
the number of
Times time
X-rays.
second? No.
milliampere per second.
Let's see.
Math
One
is
more
also
time.
very OIC.
I said time times second.
Times
No.
times seconds. Well, time is seconds, so
Oh, well,
that's close though.
Mass
Angelico,
is-
I heard you say something. What was that?
Milliampere per second, something like that?
Milliamperes times seconds. Very good. So in mass, part of mass involves seconds. It involves time. So if you reduce your mass, if you reduce your time, then you are helping to improve radiation protection. So
So I don't understand. If you reduce mass for you, because the quantity becomes less, the radiation becomes less.
because mass is MA and time combined.
This quiz over with.
Because mass contains time,
No.
There's
right?
a quiz.
That's why mass contains
So how do you define mass? Sir?
Honestly, yeah.
Mass is what into time, sir?
I spent the whole period.
Milliamperes mass is when it's
milliamperes, right? So mass includes time. Mass includes time.
So which one is the mass, sir?
What?
What do you mean? This is
Milliampere is mass, sir.
MA is milliampere.
But-
That's the seconds.
Then what which is mass, sir? By milliampere is the
Together they create mass.
Oh.
Together they create mass. You need to take both of them in account to get your quantity. So, to think about mass, the way to think about mass is, let's say that you have a factory. The factory creates an item, right? It creates a bauble. How many baubles does the factory create? Well, you need some information, don't you? You need to know how many baubles it creates each day, right? And you need to know how many days the factory is going to be working. Does that make sense? That way you can calculate how many baubles the factory is going to make. That is the same thing going on here with mass. MA, your milliamperes, involves how many X-rays, or how many X-rays are going to be produced each second, and your seconds tells you how long you're going to be producing X-rays for. So you combine those two together and you get the total number of X-rays. You get your quantity of X-rays, right? And it's based on your rate of production in the amount of time you spend producing them. So mass involves time, the amount of time you spend producing X-rays, along with how many X-rays you're producing each second. Does that make sense?
Can we go over that 15% rule? I wrote it down, but I still didn't.
Yes, 15% rule. So let's say that we have an X-ray. So we are shooting an X-ray. And we get I don't know.
Baby.
All right. Here is.
Oh.
So this is our X-ray, okay? And we're like, all right, I like this X-ray. Okay, and then we shoot. If we change our X-ray, right? If we change it up, maybe we end up shooting at with some different energies, right? And our X-ray instead looks kind of like this. So what changed here?
The color?
The color, the brightness, right? How bright our image is.
So you reduce the mass?
All right. So yes, this could be because we reduced the mass.
Uh-huh. That's pretty close.
Okay, and then over here, let's say you've got one more. Okay. And what do you notice about this one?
It's darker.
Darker, right? We should not have made it so complicated.
I think you can like select and change the color. Right?
Yeah.
All right. So we've got our three
Magic
images.
wand.
Mhm.
Yeah.
And let's say, I really like the way this image looks. Okay? So it's like, all right, how did I make this image? Well, this image was done with 100 kbp and 10 mass. I'm like, all right, looks good, but I feel like this is too much radiation. I want to reduce the amount of radiation exposure. I want to expose the patient less, give them less dose, right? I'm trying to practice a lot here. I'm trying to be a good tech. So how do I reduce patient dose? Well, which of these two variables controls patient dose?
Mass.
All right, where do you see the words patient dose? Okay, so kbp, if the photons are absorbed by the patient, this increases dose. Over here, what do we see?
Exposure time.
The more photons we have, the higher the patient dose. So I'm going to tell you, mass is your controlling factor. This here is your controlling factor, right? The more X-rays you have, the higher the dose. On this side, the higher energy those X-rays are, the easier they will pass through the patient. They're going to get less absorbed. So increasing kbp actually can help you reduce dose. So mass is your main controlling factor though. If you adjust mass, you are adjusting the dose. So my mass is my controlling factor. I want to reduce the mass in order to adjust my dose. Does that make sense? So let's say that I reduce my mass. So now I'm 100 kbp and 5 mass. Will my image still look like this? No. Correct. I have fewer X-rays. I don't have as many X-rays hitting my board. I'm not going to have as much stuff making my board dark. So which one of these images will it look like now? Correct. So 100 kbp 5 mass will give you an image that looks like that. So now I look at this and I say, well, I helped reduce the dose, which was good, but I really didn't want to change the way my image looked. I really liked the way it looked over here. Is there a way for me to keep this low dose but have the same looking image? We increase kbp by how much? 15%. Great, and this is where the 15% rule comes into play. We're like, okay, I need to do something to bring it back to the original look. I'm going to change my kbp, but not by double, right? I'm not going to double my kbp. It's only going to go up by 15%. And so when we do that, we come back to the original looking image. Comes back and looks like this. So, do we see when we would want to use the 15% rule now? Does that make sense?
So the 15% rule is also when you want a lower dose.
So 15% rule is, so it could be used when you want lower dose, but just any time you change the mass, but you want to keep the image looking the same, you use 15% rule. Yes, as you see, anytime you change the mass, your image will change looks. You want to make it look the same, you also need to change your kbp. How much? 15%. So if mass changes by a factor of 2, right? Here it went to be divided by 2, then kbp will change by 15%.
Have you ever had to apply this yourself?
Have I ever had to apply this myself? Let me think. Yes. So, let me give you an example. You all learn how to do chest x-rays, correct? When you do a chest x-ray, what are you looking for? I heard some. Okay, so specifically where?
Lungs.
Okay, so lungs, great. What else are you looking for? What other anatomy?
Ribs.
Ribs, what else? Heart. Clavicle, okay. Okay, scapula. Well, not scapula, we don't want scapula in here. But sternum, kind of. Trachea, yep, great, trachea. Okay, so, are we only looking primarily at bones? No, we're looking at a lot of soft tissue as well, correct? So, I will give you an example technique. For me, when I was doing chest x-rays, in the room, I would use something like 120 kVp and maybe 3.2 max. Okay. That was what I used to shoot my chest x-rays. But sometimes, I wasn't doing chest x-rays for the thorax. Sometimes, I was doing rib x-rays. Now, when you do the ribs, do you think we care about the lungs? Do you think we care about the heart? Do you think we care about the trachea? What are we concerned with? The ribs, the bones, right? So, when I want to look at the ribs, I take my KVP and I lower it. Why? Because it'll make it easier for the bones to absorb those x-rays. So for the ribs, I wanted to use 75 kVp. But I wanted my image to still be about the same brightness. Well, what kind of mask should I use? How would I figure out what mask I need? Do I just keep guessing until I get it right?
That's a lot of repeats.
No, I use the 15% rule. So, let's try and go from 120 down to 75. What is 15% of 120?
Are you asking?
I am asking.
15%.
No one else wants to do this for me?
18.
Very good, it is 18. Okay, so 18, which means my 120 kVp goes down by 18, so I'm now 102 kVp. What is my new mass?
Half of 3.2.
So I went down with kVp, so which way does mass go? Goes up by how much?
15%, sir.
kVp went down 15%.
Like 50%.
Mass changes by
2.
2, right? Before we were dividing by 2, that's how we did 50%.
Okay.
Now we're going up, so 6.4 mass.
See, 50, sir.
Well, I'm not at 75 yet, am I? All right, let's do this again. So what's 15% of 102?
15, right? Not 50, right, sir?
Hmm?
You do 15%, right? sir?
15%. So what's 15% of 102? 15.3. All right, so 102 minus 15.3. All right, 86.7. All right, we'll round it up to 87. 87 kVp. Okay, what is my new mass?
12.8.
Good, 12.8 mass. It doubles again. All right. Still not quite there yet. All right, what is 15% of 87? 13.15, so 87 minus 13. Yeah, pretty close, right? Pretty close. So, so
Tired of it too, huh, Mr. Trump?
So the smaller KVP gets, the bigger your mass gets?
if I want to keep the image looking the same. So 74 kVp, and what is my mass?
24 point, no, 26, no, 25.6.
Very good, 25.6 mass. And so if I wanted to keep my image looking the same, I would use 74 kVp and 25.6 mass. Does that make sense?
Yeah, so all this time I was thinking mass when you're saying the weight and SS mass. But you're actually saying milliampere seconds
Yes.
as mass.
Yes, I'm sorry, yes. If that was confusing, I apologize. But yes, we're talking about milliampere seconds mass. Now, one more final wrench to throw into this problem. What is your SID for the chest X-ray?
72.
72. Take a guess as to what the SID is for a rib X-ray.
Is it unilateral or bilateral?
40 inches.
For what?
The SID for ribs is 40 inches.
Really?
So now, I would also need to adjust my technique to account for the fact that I'm getting closer. And in that case, I would make some adjustments based off inverse square law, which we won't worry about right now.
You look too happy.
I know.
But you'll be discussing it later, so I'm just warning you ahead of time. You will see this
You look too happy.
next semester.
Yes.
Yes,
So
Shamika.
is that is 40 SID for unilateral and bilateral ribs, or?
Mhm,
Okay.
correct. All ribs are at 40 inches. Minimum. Okay, so do we kind of understand when we would use the 15% rule now?
Not on this question.
Not in this question. So the idea is that anytime I want to change mass or KVP, I need to adjust the other one to keep my image looking the same. Otherwise, I end up too dark or I end up too light.
So if you increase your KVP, you decrease your mass, and if you decrease your KVP, you increase your mass.
Correct.
I know that part, but I don't.
And then the 15% just tells me how much I change my KVP by. Yes, Jay.
With ribs being the example, how would we be able to find the, rather, what's the milligram that we should be shooting at for like ribs? If we were to try and do practice problems like that, going from chest to ribs.
So when you say what's the milligrade, you're talking about in terms of inverse square law?
Mhm. Like, what would be a number that you feel comfortable with us practicing?
So, as far as the practice question, I wouldn't do that to you because when we're dealing with adjusting mass and distance, we end up using something called a direct square law, which is just your inverse square law, but with the last two things flipped. So ones are on top, twos are on bottom, right? Here they're opposite, direct square law, they're directly the same. So that's what I would have you end up practicing with, and you would never need to worry about intensity itself.
Okay.
Well, hopefully you'll be out of labor by the time we get to direct square law.
I think everyone's worn out already.
Everyone's already okay, I understand. We have been talking for quite a while.
Yeah.
Okay. So I just want to make sure, are there any other questions about chapter 1? So I know inverse square law, that's always a big one. 15% rule, also very big, very important.
I think those are the two.
Those are the two major ones. Right. So everyone's okay with the concept of beam restriction?
Yes.
Right. Not only does it help you reduce patient dose, but it also improves your image quality. So we're okay with shielding, we have our barriers. Okay, we know about that.
Could you go back to the shielding, like the numbers? Primary, okay, 1/16 and 32. Thank you.
We're okay with these different things, the tube, table, wall stand, control panel, floral table. Those of you who are at the hospitals, have you had a chance to just peek in the floral department? Take a look at the floral table.
But I have a question.
Yes.
About that. So, Thomas Street,
Yes.
how do we get there again?
Ah, okay, great. So let's just do a little bit of housekeeping as far as lab goes, and then I will dismiss you.